Alright, hello AP Physics 1 students. It is time to finally wrap up our unit on dynamics, and today we're going to do that by talking about inclined planes. So, what is an inclined plane? Now, an inclined plane is it's basically just a ramp. So because it's tilted, any force acting on an object on the inclined plane will have a horizontal and vertical component. This includes friction, normal force, etc. And yeah. So here's the thing about our inclined planes. We can't really use our normal coordinate system to do it because, as you can see, if we have our y-axis just going straight down and our horizontal axis just going straight left and right, there's going to be some problems with the forces being applied to an object. So as we can see, our normal force is going to be diagonal, our friction is going to be diagonal, and so is our acceleration. Now this becomes a problem because now they have to be broken up into x and y components, and that just makes calculations really annoying. So, to solve this, all we have to do is rotate our coordinate system. If we rotate our coordinate system so that our x-axis is parallel to the surface of the ramp and the y-axis is perpendicular, this becomes much less of an issue. Now, as you can see, our normal force is perpendicular to the surface of it, our friction is parallel to the surface, and our acceleration is parallel, and now only our force of weight has to be broken up. And how are we going to do this, I hear you asking? Well, we got to use some trigonometry. As I'm sure you all noticed, we have a right angle here, which means right triangle, so the trig's going to be super easy. And if an object with a mass m is on the ramp, then the force of gravity has two components. We have our component that's parallel to the ramp, which is right here, or right here in this little picture, which is going to be mg sine of theta, or force of weight times sine of theta. And then we have our element that's perpendicular to the ramp, which is right here, so mg cosine of theta. Now, because this is parallel to the ramp, the force driving the block down the ramp is parallel, which means we're going to be using our mg sine of theta. Now, our mg cosine of theta is perpendicular, which means that's mostly going to be used for our normal force, because as we know, normal force is perpendicular to the surface. Alright, let's go ahead and look into an example. So, a block slides down a frictionless inclined plane at a 30-degree angle. Find the acceleration of the block. Alright, so what we're going to do is we are going to draw a picture. Now, we have our 30-degree angle right here, and we have our force of weight broken into our perpendicular and parallel components. So we know that our force that's driving it down is going to be mg sine theta because it's parallel to the surface. Okay? Now, we also know that force equals mass times acceleration, and we can isolate acceleration and just get it equals force over mass. And if we plug in this equation for our force into our acceleration formula, we get acceleration equals mg sine of theta over m. Now, the great thing about this is we have m in the denominator and m in the numerator, so we can just cancel those out. And we get our acceleration equals g sine of 30. Now, sine of 30 is 1/2, so we get g times 1/2, or 5 meters per second squared. Easy enough? Alright. We are going to go add on to this example a little bit more now. Example 2. Find the acceleration of the block in the previous example if the coefficient of friction is 0.03. Alright. Once again, we're going to draw a picture, and now notice that we have more forces being applied. So we have our force of weight sine theta that's driving it down, our force of friction that's opposing that motion, and our normal force, which is just going to be the same as our force of weight times cosine theta because it is perpendicular to our surface. Alright, we also know that our theta equals 30 and our coefficient of friction equals 0.03. So, first thing we're going to do is we're going to solve for our friction. Or at least get a formula for our friction. So we know that friction equals mu times normal force, and as we said earlier, our normal force is just going to equal force of weight times cosine theta, so we have mu times force of weight cosine theta. And we also know that force of weight is just mass times gravity, so we get mu times mg times cosine of theta. Alright, now, to find our acceleration, we need to use our net force, so we know that that's going to equal our force driving it down the ramp, or our force of weight times sine theta, minus the force that is opposing that motion, or our friction. Now we're just going to go ahead and plug in what we got for our friction, and since it's force of weight sine theta, we can substitute in mg for force of weight. So we get mg sine theta minus mu mg cosine of theta. Now, one thing you're going to notice is that we have an mg in this one, and we have an mg in this one. So, as my calculus teacher likes to say, it's time for our favorite F word, factoring. So we can just take our mass times gravity and put it outside of the parentheses. So we have mg times sine of theta minus mu cosine theta. Now, if we look right over here, we have our force equation again. So we have force equals mass times acceleration. Once again, we're going to isolate acceleration, and we get acceleration equals force over mass. Now, if this is our net force, we're just going to plug it in right over here, and we're going to get our acceleration equals mass times gravity times sine theta minus mu cosine theta over m. Now we have m in the denominator, I hate this little tab at the bottom, and m in the numerator, which means it's time to cancel. We cancel out our m's, and we get our acceleration equals g sine theta minus mu cosine theta. Now all we have to do now is we have to plug in. So g is 10 sine of 30 and cosine of 30, and our mu is 0.03. We get 10 times 1/2 minus 0.03 times rad 3 over 2, because that's our cosine of theta, and we get that that equals 2.4 meters per second squared. Alright, so I hope that was helpful. That's going to wrap it up for our inclined plane lesson. Just remember, it is a whole bunch of trig, but it's super easy trig. You don't need to know any of your trig identities. You just need to know parallel is sine and perpendicular is cosine. The big thing is just remembering which trig function you are using. I mixed this up all the time when I first started looking at it, when I tried to do it without checking my formulas when I first started doing that. But just gotta remember, parallel is sine, perpendicular is cosine. Alright? And make sure you're drawing a picture, especially considering it's rotated now, so you need to know which forces you're looking at and which force is going where. It's super important to remember that. It's super important to remember because you need to remember to use your trig. Alright? I hope this was helpful, and I will see you in the next lesson and the next unit. Until then, cheers!